All right. Good morning, everyone. My name is Jesus Enriquez. I'm the team leader.
My name is Oli Koban. I was in charge of logistics.
My name is Deep Mystery, and I'm hardware and software support.
My name is Locko, and I'm the software specialist.
Hi, my name is Deo Joe. I'm a component specialist.
And our project is the Sound Compass. So I'm sure many of you have heard this sound before. If you could hear that sound, you probably identified at least two things about it. First, you know that it's some type of a smoke alarm. Second, you know it came from that general direction. Now imagine that you're one of the 466 million people worldwide who suffer from some form of debilitating hearing loss. You probably couldn't even hear the sound, much less tell me anything about it. With that in mind, we've developed a device, a tool, that we hope can improve the quality of lives for all those millions of people.
The Sound Compass is a low-power, low-cost, and compact device which can be worn on the wrist. The main functions of the Sound Compass are to detect sounds above a certain threshold and to indicate to the user the direction and source of the detected sound signal. For example, if the detected sound signal originated from a type of emergency signal, the device will indicate to the user the specific type of emergency siren and indicate the direction of origin of the sound signal. To detect the sound, we are using an array of 8 MEMS microphones, which feed into a TNC 3.6 microcontroller through a custom-built PCB. Once the microcontroller processes the data, the device will vibrate a small motor to alert the user's attention. The device will then indicate the appropriate information on a 1.8-inch LCD display.
For sound localization, we implemented a technique that compares more than 10,000 data points from each of the microphones. As you can see here, one of the biggest challenges we had was calibrating the microphones. When we first received them, they picked up the same sound at different levels. As you can see on this graph here on the bottom left-hand side, we had to calibrate all the microphones. We picked 840 hertz as our calibration frequency, because that was one of the most common frequencies we detected when testing. For Siren Detection, we implemented a correlation-based technique where we decomposed different sirens and alarms into their frequency components and used our device here to compare the different frequencies. If you can see, it's kind of hard to see, but here, that plot right here has the breakdown of the emergency alert system frequencies. And next to it, you can see the device in operation, detecting the direction and the type of frequency, that type of sound.
Now, the next time a smoke alarm goes off, even those who suffer from hearing loss can be alerted to the potential dangers in their surroundings. We hope that with the Sound Compass, we can improve the lives of those who suffer from hearing loss. Thank you.
Right. Any questions?
Were you able to test in some type of environment that a smoke alarm would go off, such as a smoke-filled room or something of that nature?
Not in a smoke-filled room, but we did test it in our lab downstairs. There's a lot of alarms that go off. The door alarm keeps going off, for example. And our system can easily pick that kind of thing up in that kind of a room, yes.
Okay.
Did you do any testing and kind of along the same page where, you know, there's a smoke alarm, there's going to be people screaming or whatever,
Right.
Did you test to see if you could like ignore that background noise and really pick out the alarm?
Yes, we did. So part of our testing, part of our simulations, we included some background noise. We actually picked up a YouTube video where people were just talking, and we ran through our tests. We actually included part of our correlation data, the frequencies from background noise. So that's already been factored in.
In terms of the size of the device, it's relatively large for somebody to wear all the time. Do you have some vision of how small you could make the device and how it might be implemented in a watch or something that would be already somebody would typically be wearing? Right.
So size-wise, to be able to detect sound coming in from different directions, we have a certain spacing, 1 inch between the microphones is our minimum size. It can be made thinner, it can be made lighter, but as far as the distance between the mics using our particular system, we can't shrink it any smaller than 1 inch between the mics. But it can be thinner, for sure.
Thank you.
Right. Any other questions? Then we can thank the team.